Today we're going to go over the visitor pattern. We're going to begin understanding this pattern by thinking we have some HR system. We have this class called the employee class that we use as the top level to implement all the different employees that exist in a company. So we'll have engineers, managers, maybe interns. In this system, we're going to want to process some payroll. So we might add this method, process payroll, to all of the different employee class members. Later, we might want to add a generate report. Later, we might also want to add compliance reports. Later, we might want to add tax calculations, performance reviews. We're always constantly adding more and more and more different HR operations in our system. Every time we do, we notice that on each of those different employees, we're going to have to go inside, adjust different logic. And once we do that, we notice that all of these different employees, it becomes much more tedious, much more complicated, and everything starts to look similar, starts to look different as well. Anytime we change one thing, we notice we might change, it might be changing all the different employees. It's all coupled together, it's all mixed up. If we think about this, there should be an easier, better way to implement this HR system, and we have the visitor pattern. When we first think about the original problem with the visitor pattern, we notice that we might first just create this class. We might create those different employees separately. We might create an engineer class, which implements the process payroll, the generate report, and we'll do the same thing again with the manager class. But both of these will just have different logic for each one. We add another method like calculate tax. We're going to have to edit the engineer class, and then we're going to have to edit the manager class as well. If we add another new class, like an intern class, we're going to have to implement all of these operations there as well. We're already seeing that the hierarchy and the operations are all tangled together. If we think about this, this is what the visitor pattern is trying to fix. The pattern overview, we're first going to think about the visitor pattern as a behavioral design pattern from the beginning of 4. They defined it as represent an operation to be formed on elements of an object structure. Visitor lets you define a new operation without changing the classes of the elements on which it operates. So the behavioral patterns themselves are about communication, how objects collaborate and divide responsibility. The visitor pattern is a pattern you reach for when you want to add new behavior to a class hierarchy without modifying it. The root of the mechanism that makes all this work is called the double dispatch. Unlike normal method calls, if we think about the runtime picks a method depending on the receiver type, this idea of the double dispatch uses 2 type lookups to route to the right code. If that's not making much sense, we're going to just look more carefully into what that means. This pattern has 4 different participants. This is how this demo is laid out. So first we have the element interface. This is the employee, and it declares the accept method that every other concrete implementation must implement. The concrete elements, we have engineer and manager implement the accept by passing themselves to the visitor. This is what we mean by the visitor.visit, the class. The visitor interface, the employee visitor, declares the visit operation, and then the concrete visitor, the payroll processor, implements the visit with the actual business logic. The flow is that the client calls the employee accept the employee accept method to the visitor, which calls the visitor visit method this, which applies the visitor logic to the concrete element. We just have 2 hops and then 2 type lookups. That's where we have the double dispatch. First, we're going to talk about the employee class. the element interface itself is defined inside the employee Typescript file. It carries three data fields. It has the name, salary, and the department. The critical method we have is the accept method that takes the employee visitor. Every concrete employee type is going to have to implement this. It's a hook that enables this double dispatch. The employee interface doesn't know anything about anything beyond this class. It doesn't know about payroll rates, report formats, or tax rules. All it knows is that this is how it's going to accept a visitor. This whole clean separation is the whole point of this visitor class. The next we're going to look at is the employee visitor. And this is the visitor interface. It's a single method. All it is the visit method, and that's it. It's so simple. So once we add new operations to the system, it means that we're just writing a new class that implements the employee visitor. If we add a tax calculator, a compliance reporter, a performance reviewer, all of these new classes just implement from this one interface. You don't ever touch any of those concrete, you don't ever touch like the employee class, the engineer class, or manager class. This is the open close principle in action. We have the system that's open for extension, but it's closed for modification. Next, we have the participant engineer. This is the concrete element. It has a constructor that accepts the name, salary, and department, and there's just a single line for the accept implementation. Passing this in the visitor.visit method is a crucial step. The this keyword inside of the engineer accept method is, this one is typed as the engineer class, the class itself. It's not tied to the employee class. When that reference reaches the visitor can just check the instance of manager, checking see if it's that type. It's going to be false. If it does this, then it knows that it's dealing with an engineer. Engineer doesn't have any knowledge of bonus rates. It's just a passive data carrier. All the logic will be within the visitor. Here we have the manager. The code is the same thing as the engineer. We have the same way we have the constructor, the same accept method. The only difference is just the class name. And the name of the class is what the visitor will detect. When we run that manager accept payroll processor, when we run it calls the payroll processor visit method, the this that's passed into the payroll processor visit method is going to notice that it's going to be the manager type. The visitor is going to make that check. It's going to return true. And then that's when we execute the difference bonus rate. It would be 20% in this case. So the symmetry that we have between these two classes is intentional. If we add another type, like let's say we add an intern class, it means that we're just writing another class with the same exact pattern. We don't have to change either the manager or the engineer class that we've already had. Here we have the payroll processor. This is the implementation of the visitor itself. All it's doing is just doing one check, and this is like a type check. If it notices that it's a manager, it will do 20%. Everyone else is going to get 10%. The result is stored in this last result variable. This one is like a DOM safe pattern. It avoids the alert method. And from here, we have the entire payroll algorithm within this class. If the rules change, like we have engineers get 12%, all we have to do is edit this class, the payroll processor. We don't have to touch any of the other classes. Here we're going to look more closely at the employee and employee visitor classes side by side. If we see the employee accept method, it takes that employee visitor, and the employee visitor has the visit method, and it takes the employee. We have this circular contract. They're both referencing each other. The mutual reference is what creates this dispatch loop. Each interface knows about each other, but neither knows about the concrete classes themselves. That indirection is the foundation of the entire pattern. Now we're going to look at the engineer and manager together. We see that they're exactly the same thing. The accept method is basically copied and pasted together between them. The interesting thing, if you look at both of them, is they look the same, but they are totally different types, the classes themselves. And that type difference is how this entire mechanism works. The visitor uses that type-specific logic to create that differences in how it executes the behavior. This is the first dispatch when you call in the engineer accept visitor versus the manager accept visitor. Once we do this runtime, whichever accept calls is based on that concrete type. Even though you think that they do the same thing, they will be executing different behavior because the concrete type that calls the visitor will be different. And the visitor will be able to pick up on that. This is the entry point, the index TypeScript. This is how it gets all instantiated together in the beginning. So the client creates the element, it creates the visitor, it calls the employee accept payroll processor, and that one line will trigger the full dispatch chain. The entire index TypeScript, this file, we're just doing all this different writing or routing, attaches the process salary function to the two button click handlers. The entire entry point here has no business logic at all. It just maps to the user interactions to the client function. That we have for the visitor pattern. Here is the flow. Simply, we have these concrete contexts or elements that's accepting the visitor, engineer manager. It has this method accept on the payroll visitor. Here, the visitor calls the visit. It's going to go back. We have the double dispatch. Whichever concrete class has called onto the visitor will create this different behavior here. Looking at the code, starting at the TypeScript index file, we have this event listener. This means that it's going to call this on the page load. A lot of the implementation here is actually in this one, the process salary. So looking at here, we first will create either a engineer or manager. And so here we're creating this through either this button click or this button click. So here we're just quickly creating those different classes here. When we create either one of those classes here from the employee, next we call this payroll processor here. From the very beginning, we see that both of these just called the accept method. They both are implementing the same on the visitor, just the visit. Passing in the payroll processor to the employee, since we know that these are totally different concrete class implementations. On the payroll processor, here we have the visit that should handle both of these. It's going to take that employee, check the type, and based on that type, it will implement a different bonus rate, change in behavior. Because we're doing that, we can call this last result, which here for the payroll processor, the last result is that bonus rate and new salary. And that's set by the visit. And this kind of continues on to process the salary here. A really important part of this whole implementation is understanding, again, this double dispatch. These two are connected together. It's going to accept the payroll processor. The payroll processor is going to accept a employee, because these two are taking each other's interface, once it calls the visit, then from here, we can actually then look at the concrete type that we have here from the employee and say, hey, if it is that specific type, then we can understand that this behavior should change accordingly. And from here, we can see that the behavior changes just the rate that is being applied to the salary. Here, we want to think about when we want to use this pattern. An important part of this pattern is understanding that your type hierarchy is stable. The types won't change. What we want to do is keep adding these operations frequently, though. The best example is think about what we just showed and demonstrated is this HR reporting system. The employee types are stable. We have managers, we have engineers, we have contractors, and we're always adding maybe more operations like calculating payroll, calculating tax, calculating compliance. Here we can just add separate visitors to keep adding on these operations. Another thing we can kind of think about is document processors. Document structure is fixed. When we add exporters, validators, and formatters, we can implement these as visitors. And the important part is also considering that performing the visitor pattern will keep all the operation logic centralized. We're not separating or scattering these across a class hierarchy. This is more beneficial when we add on more and more number of operations. If it's just like a single operation, we can just go to a method implementation. So it's not that complicated. We don't want to go through here. But when we have more and more operations, like 10 operations, this might look a much better in that aspect. When we want to not use the visitor pattern does have real costs. We want to avoid it when the hierarchy might change frequently. Every new element type will require updating every visitor. If we have if we add the intern today or we add a contractor, we're going to have to update the payroll processor. If we had like a tax visitor, we'd have to update the tax calculator. We're going to understand that we have to update all of those different visitor classes as well. You only can have one or two operations. The idea of the accept and visit overhead might not be worth it for a really, really small system. Also, understanding encapsulation matters. The visitors often need access to an internal state of elements because we're having this double dispatch between the two, so this might break object boundaries. And TypeScript has this thing called discriminated unions. This might be a bit better for simple algebraic data types. We could use a switch statement with exhaustive type narrowing. This might be cleaner and more type safe than having this double dispatch. Real world analogy for using the visitor pattern, just to make it more understandable, is if a tax auditor visits a business, the auditor has a standard audit process, but it applies different rules for restaurants, retailers, and manufacturers. The businesses don't change these operations to accommodate the auditor. They just accept the audit. The auditor just carries that inspection logic. We can also think about a doctor doing a checkup. The patient accepts the doctor. The doctor examination procedure will depend or vary on the patient type. If we think about a pediatric checkup or sports injury assessment, it's going to be completely different how the procedure will go through. And the patients don't encode the medical procedure. It's the doctor that will have the logic for the patient. And also a museum tour guide. If we think about the exhibits, they're going to have different tour guides. There might be a history guide, an art guide, a children's guide. Each guide will interpret the same exhibit completely different. The exhibits are passive. The visitor changes these interpretations. So in all these cases, we have stable elements. There's interchangeable visitors. The logic is all in the visitor themselves. When we compare the visitor pattern between the other types of patterns. We have first the strategy pattern. It also encapsulates an algorithm, but it's in a totally fundamental different way. The strategy will only swap one algorithm on one host object. The algorithm is injected to the host, and the host will call it. There's no type hierarchy dispatch. The visitor adds many operations across a whole different hierarchy through this double dispatch. The idea is if you're thinking, I just need to add an operation to every class in my hierarchy, then we want to think about the visitor pattern. We have this decorator pattern as well. It adds behaviors by wrapping objects. The wrapped object looks the same to the caller. Decorators are structural. The visitor is behavioral and external. This means it operates on elements without wrapping them, and it uses this double dispatch to route to type-specific logic. A decorator doesn't know or care about the concrete types it wraps. A visitor is explicitly designed to distinguish between them. In summary, there's 3 specific things to remember about the visitor. There's separation. The algorithms live in visitor classes. It's not in the element hierarchy. In the example, the engineer and manager will stay clean of the data objects. We have the double dispatch. The accept method calls the visit method on this. We have the 2 type lookups, one dispatch chain. The element type and the visitor type together determine which code will run. We have trade-offs. The trade-offs that we have is that the visitor is a great type when your type hierarchy is stable and operations keep growing. It does become a liability when new types are continuously being added, so then we're going to have to modify the visitor as well. We want to just consider the pattern to the stability of the system. The source code of the demo is within my repo. The link is in the description. If you want to go deeper, then you can go check out the Gang of 4 chapter on the visitor. It's going to go more into detail on the context that can kind of explain more of that double dispatch. It might be better to originally go to that reference. The next pattern that I'm going to go through is the iterative pattern that's going to just go more into traversing hierarchies without exposing that structure. If you want to learn more about this pattern and understanding more on the algorithms or patterns that kind of go through behaviors and adjusting algorithms, we have the strategy pattern. We're going to swap algorithms on a single host, and we have the composite pattern for these tree structures that the visitor will commonly walk. If this was helpful, then if you can hit subscribe, I'm going to continuously make more patterns in the series, and each one will kind of build on the last one. All right, see you next time.